Who's ready to do some more factoring? Well, I certainly am. So let's take a look at some factoring shortcuts. First, we're just going to start with a problem that we should all be able to factor very easily. X squared plus 6x plus 9. So here, because the coefficient of x squared is 1, all we have to do is find two numbers that multiply to 9 and add to 6. And those would be 3 and 3. So this will be x plus 3 times x plus 3. Now notice that since we have x plus 3 times itself, we can rewrite this as x plus 3 squared. Okay, let's look at another one like that. X squared minus 10x plus 25. Two numbers that multiply to 25 and add to negative 10. Well, we know the two numbers that would add to 10 would be 5 and 5, so in order to add to negative 10, we're just going to use negative 5 and negative 5. And once again, this can be rewritten as x minus 5 times itself, or x minus 5 squared. So I think you see the pattern here. There's something about these trinomials that allows them to be rewritten as one binomial squared. So I'm going to write a formula, and hopefully this should look pretty familiar. So if you remember a few videos ago, we did algebraic expansion shortcuts, and one of the formulas I gave you was essentially this formula in reverse, where when you started with a plus or minus b squared, you started with something like this, x plus 3 squared, x minus 5 squared, and you could end up with this, a squared plus or minus 2ab plus or minus b squared. You'd end up with the trinomial. So what we're doing in this video, since we're factoring, is we're just doing that in reverse. So let's take a look at this. What we're going to do is put this into this binomial squared form in one step. But in order to make sure we can do that, we have to check to make sure that it fits with this formula. So if you see here, we have 2ab. 2ab is the coefficient of x. That means the coefficient of x, since the coefficient of x squared is a squared, and the coefficient of the constant is b squared, then in order to get a and b from a squared and b squared, what we're doing is taking the square root of the coefficient of x squared, and the square root of the constant. So the square root of the 1 here is 1, and the square root of 16 is 4. So a is 1 and b is 4. Now we have to make sure that the coefficient of x is 2ab. So 2 times 1 times 4 is going to be 8. And we have that here. So because of this, we can factor this in one step. A squared plus 2ab plus b squared equals a plus b squared. So a is 1, so 1x, and b was 4, so x plus 4 squared. Done. The same thing will work if we have minus 2ab. So 1 is a squared, and 36 is b squared. So we take the square roots of both. Square root of 1 is 1. Square root of 36 is 6. 1 times 6 times 2 will be 12. And we have 12 here, but it's negative. Because it's negative 12, we follow the formula. A squared minus 2ab. Sorry, there shouldn't be a minus there. Okay. A squared minus 2ab equals a minus b squared. So this will be x, not plus 6, x minus 6 squared. because b was 6, and the formula says to put a minus b, so 1x minus 6. Okay, let's do one more like that. So by now, hopefully, you're getting the habit of this. The square root of 1 is always 1, of course. So if you see just x squared here, you can just ignore that. All you have to make sure is that this number in front of x is twice the square root of this. So square root of 81 is 9, and 2 times 9 is 18. It's negative 18, so this is not going to be x plus 9 squared. It's going to be x minus 9 squared. Okay, now let's make things a little more difficult by adding a coefficient other than 1 in front of x squared. So now we have to go back to the formula and be very careful here. We're taking the square root of both a and of b. Square root of 4 is 2. Square root of 1 is 1. So 2 times 1 times 2, since it's 2ab. 2 times 1 times 2 will be 4. And we do indeed have 4 in front of x. So now we have confirmed that this is a squared plus 2ab plus b squared. So to put it into this form, we're going from a squared to a. The square root of 4x squared is going to be 2x plus b. The square root of 1 is 1. There we go. Okay. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 times 2 is indeed 12. So this one works as well. This is a squared plus 2ab plus b squared. So a will be square root of 9x squared is 3x plus square root of 4 is 2. There we go. And now we'll bring in our negative. Square root of 16. Oh, well, first let's check this. We have, square root of 16 is 4. Square root of 25 is 5. And 4 times 5 times 2 is 40, so this works. So now we have a squared becomes a, so 16x squared, we take the square root of that, it becomes 4x. But then, because we have a minus 2ab means we have minus b in the factored form. So minus the square root of 25 minus 5. I figured I would throw this one in here, see if you remember what to do. Whenever you have a negative in front of x squared, the first thing you should do is factor that out. So this is going to be negative. And then all the signs change. So this will be positive 9x squared plus 24x minus 16. Sorry. This should have been a minus, so this will be plus. Okay. And now we can factor this. Well, let's see if we can. Square root of 9 is 3. Square root of 16 is 4. 3 times 4 times 2 is 24. So now to factor this, remember to keep the negative outside there. Negative square root of 9x squared is 3x plus square root of 16 is 4 squared. Okay. we will check this one. Square root of 4 is 2. Square root of 49 is 7. And 2 times 7 times 2 is going to be not 35, that's for sure. 2 times 7 times 2 is 28. So this is actually not factorable using this shortcut. And the reason I threw this in here was because it looks like it will be, because both 4 and 49 are perfect squares, meaning you can take the square root of them and get a whole number. But this one is actually not. That's why it's good. That's why you have to check that this is indeed a squared plus or minus 2ab plus b squared form before you can factor using this method. So we're going to have to factor this using the traditional method that we went over in the last few videos. Draw the x here. Factors of 4 are either 1 and 4 or 2 and 2. Because 35 is fairly large, let's just guess that's going to be 1 and 4. Factors of 49 are 1 and 49 are 7 and 7. 49 seems like it would be way too large. So let's go with 7 and 7. Now we multiply across, we'll get 7 plus 28. That is indeed 35, but it's negative 35. In order to make it negative 35, we're going to put negative in front of here and negative in front of here. And negative 7 times negative 7 will still multiply to positive 49. So now we can, from this, write x minus 7 times 4x minus 7. Okay. So now let's introduce another factoring shortcut for a different type of problem. Something that looks like this. Again, I'm going to write another formula that hopefully will look familiar. And once again, it's a formula that we introduced in the expanding algebraic expressions video. But again, it is backwards. Instead of starting with this form, we're starting with this form, as you can see right here. So all this is saying is when you have a squared minus b squared, meaning the coefficients of x squared and the constant are both perfect squares, then we can write it like this. Square root of 1 is 1. Square root of 4 is 4. So the square roots are a and b, since we started with a squared and b squared. So square root of x squared is going to be x plus b, so it'll be plus the square root of 4 plus 2 times x minus the square root of 4, x minus 2. For this one, we're going to do the exact same thing. Square root of 1 is 1. Square root of 121 is 11. So this will be x plus 11 times x minus 11. Now, if we have a number in front of x squared other than 1, then square root of 4x squared is 2x, not just x. 2x plus the square root of 25 is 5 times 2x minus 5. Now for these, because there's only two terms, you don't have to check. There's no middle term. There's no x term, so you don't have to check to make sure it works first. If you see this, both the coefficients of x squared and the constant are both perfect squares, then you can do this method right away. Okay, square root of 16x squared is 4x plus square root of 124 is 12 times 4x minus 12. Now, in this one, you should notice that 4 and 12 have a common factor, meaning something can be factored out of this whole expression. And that's going to be 4. We can divide both 4 and 12 by 4, meaning this will turn into factor out a 4 of the whole thing. 4 times x plus 12 divided by 4 is 3 times x minus 3. The reason the 4 factors out of both expressions at once is because in this final answer, the 4 is actually being multiplied by both of these. In other words, if we were to multiply these back together first, the 4 would multiply by the whole thing. So you could factor the 4 out, and it comes out of both of these expressions. Now, if you notice that you're going to have something where a fact can be factored out in the end, you could have noticed that here 16 and 144 are both divisible by 9. So in here, you might notice the same thing. 9 and 81 are both divisible by 9. So the other option is to factor that out at the beginning. You factor out a 9 right away, and you're left with just x squared minus 9. And that we can very easily see is 9 times the square root of 9 is going to be 3. So 9 times x plus 3 times x minus 3 using the formula up here. Okay, I believe that is going to be it for factoring. These are some important factoring shortcuts that you should get to know because you will see them again, most likely. But with this video, that's going to conclude factoring. For this playlist, it will come up again a lot in the next series of videos on quadratic equations.